good morning. Here, it is the first topic from the first unit, that is what block diagram of an op-amp. So here in block diagram of an op-amp, total we have 4 blocks. The first one is double-ended differential amplifier. Here, double-ended differential amplifier in the sense for this amplifier, we have to give 2 inputs and we have to get 2 outputs. So that is called as one double-ended. 2 inputs for the op-amp, two inputs for the differential amplifier and 2 outputs we are getting from the differential amplifier. So that's why it is called as one double-ended differential amplifier, which provides maximum voltage gain. That is what AV, right? So when we get the maximum voltage gain, here the voltage gain expression AV equal to V naught by V, the output voltage divided by the input voltage. So whenever we have the high output voltage, so that we can get the high voltage gain, right? So next one, the output of the double-ended differential amplifier is applied to the single-ended differential amplifier. Why we call it as a single-ended differential amplifier? Even though we have 2 inputs for the single-ended differential amplifier, at last we have only one output. That is what we have for the single-ended differential amplifier. The output of the differential amplifier, that is single-ended differential amplifier, is applied to the emitter follower. And you may ask one doubt, then what is the purpose of having single-ended differential amplifier? Because we have already used double-ended differential amplifier. So again we are using the differential amplifiers block in our operational block diagram of an op-amp. So in order to provide the additional gain, right? So the first differential amplifier which provides high gain. So even though we are using the double-ended differential amplifier in our block diagram, again we are using one more differential amplifier. Actually, in the block diagram of an op-amp, I have shown you only 2 blocks of differential amplifier. But the first one, apart from the first one, the single-ended differential amplifier stage is also called as the intermediate stage. It is not compulsory to have only 2 differential amplifiers in our block diagram of an op-amp, right? So we may have many number of differential amplifiers. In the circuit of an op-amp, we may have any number of differential amplifier. Okay, all these differential amplifier are used to provide high gain for the op-amp. Here, the op-amp ideal characteristic, that is one of the very important ideal characteristic of an op-amp. The first one is what the op-amp should provide very high gain. Ideally, it is infinite, but practically it is in the order of 10 to the power of 6. Right? And next one, the op-amp should have infinite input resistance. Right? So the op-amp terminal should not draw any current. And next one, the output impedance of the op-amp is 0. These 3 are the ideal characteristics of an op-amp. We never design an ideal op-amp, right? So, but these are the characteristics of an op-amp. We never see the ideal person in our real life, right? So those are the qualities. We have some qualities for the ideal person, but we never get or we never see the ideal person in our daily life, right? So next one, after the single-ended differential amplifier, the output is applied to the emitter follower. I think you have an idea about emitter follower. Then what does it mean? Emitter follower in the sense, this is called as what? CC configuration, that is common collector configuration, right? So here in the emitter follower, V naught equal to V, that is what? Gain equal to 1. The expression for the gain equal to AV equal to V naught by V. So whenever input and output both are same, okay, the gain will become 1. The emitter follower circuit will have the unity gain and the high input resistance and low output resistance for the common collector configuration. Why we are using this emitter follower circuit in the block diagram of an op-amp? Here, the output of the differential amplifier, the single-ended differential amplifier, is directly fed back to the output driver without any changes. The output is equal to input, and here the emitter follower circuit will have high input resistance. Now this emitter follower configuration is also called as what? So it is the level translator, and it is also called as the buffer, because here we are not going to change any modifications or any modification for the output which is coming from the single-ended differential amplifier. We are just storing the output. Okay, so we are storing the output in the sense what? It is called as buffer. It acts as a buffer, and it is also called as what is the level translator. Okay, what level it is going to be translated here? Only the DC level, because here for every stage which are present in the block diagram, we are not going to use any coupling capacitors here, right? So what is the purpose of using coupling capacitor? The capacitor blocks DC, which allows only AC, right? But here we are not using any capacitors, means the DC is happily extended and it is passed from one stage to other stage. So here upon passing the DC level from one stage to other stage, the DC level will be higher and higher as we are moving from one stage to other stage. So in order to block the DC, or in order to reduce the DC level, we are using what? Level translator. That level translator is going to reduce the level of DC below the zero. Okay, that is the purpose of using buffer and level translator. And next one is what? Output driver. Generally, the operation amplifier output is applied to the speaker. It is going to amplify your voice or your sound, right? So, the output driver should have very low output impedance. Here the output driver, large output voltage or current gain. The output driver is going to have the large output voltage or current gain. So it may be voltage gain or it may be current gain. Right? So here why we are choosing this emitter follower, in the sense low output resistance. Low output resistance in the sense what? The resistance which is present at the output of the emitter follower is very low. So whenever we have the low output resistance for any circuit, the voltage drop will be very less, because very less voltage will be dropped across the smaller value of the resistor, right? So whenever we have less voltage drop, in the sense what? Almost all the input voltage will be applied to the next stage, or it is passed to the next stage. So we can amplify the given signal as we require. Okay, these are the four parts which are very important in case of block diagram of an op-amp, right? So one more thing, I think you have an idea about transistor configurations, right? So we have common base configuration, common collector configuration, and common emitter configuration, right? So out of three, here we have chosen emitter follower. The other name for the common collector configuration is what? Emitter follower. Directly the input is applied, the input and the output terminal, these two are connected. The output is same as your input. That is the purpose of using emitter follower circuit. Whenever is there any need for having unity gain, then we can consider the emitter follower circuit. And one more thing, is a very important thing you have to remember is the characteristics of an op-amp, ideal characteristics of an op-amp. It's a very important question, and this is asked in big paper so many times. What are the ideal characteristics of an op-amp? The input resistance of an op-amp should be infinite, and the output resistance of an op-amp should be zero, and the open loop gain should be infinite. But practically, infinite gain is not at all possible. So we may have 10 to the power of 6 open loop gain. Okay. enjoyed this session. In the next class, I'm going to discuss about the virtual ground concept. It's a very